All right, hi everyone. I'm recording a video for Section 8.2, which has to do with law of sines. Well, let's start off with an example, just as a reminder on how to find inverse functions on your calculator. So in this example, they're asking us to find the inverse sine of 0.58. What is this really asking you? Well, this is asking us find an angle, we'll call it theta, whose sine is 0.58. So you should be able to find this angle. If you did take sine of that angle theta, you would get the answer 0.58 on your calculator. But how do you find the angle when you know the value of the sine? This is where the inverse sine comes in. So this notation, when you see the exponent -1, remember that really doesn't mean an exponent -1. It's just a notation to say you're looking for the inverse sine. Well, if you go on your calculator, a scientific calculator, you'll find a sine button, and usually right above it is the inverse sine function. So you usually have to press like a second function or some function to be able to invoke this inverse sine function. So all we have to do is go to a calculator and type in inverse sine of 0.58. Now, the only thing you got to be careful about is when you do this on your calculator, be sure your calculator is in degree mode. So usually you can set up your calculator. There's a mode button or some other similar button that allows you to switch between either degrees or radians. In our example, we want to stick with degrees because I notice the answer box says my math lab wants degrees. So just make sure your calculator is set to degree mode. So when I work this out on my calculator, I'm coming up with the answer of 35.45 degrees, but I'm noticing it says round to 1 decimal place. So our answer here is 35.4 degrees. So let me type that in, 35.4 degrees. Let me double check if I entered that correctly. I'm sorry, I should have rounded this 35.5 degrees. Whoops, my mistake here. Let me fix that. This should have been 35.5 degrees when rounding to 1 decimal place. So 35.5 degrees for this one. All right, let's go to another example here. Let me go to the next example that says solve a triangle. Okay. All right, so let's take a look at this example. Now, notice the question here is solve the triangle to the right. Well, when they say solve the triangle, what they really ask you to do is find any missing sides and angles. So I'm noticing in this example, they're asking us to find angle A. And then they're going to ask us to find side A, side B, and this other side is given as 8. Now, it's always a good idea to label the triangle to begin with sides A, B, and C. So I'm going to call this bottom leg side C. And then I label the angles using the same capital letters that are opposite the sides. So if the bottom leg is side C, I'm going to label this angle side A. And that means I'm going to label this angle as angle B. All right, well, they want us to find the missing angle A. Well, that's actually going to be straightforward because when you look at angle A, you can make use of the fact that all 3 angles have to sum to 180 in a triangle. So that means angle A is going to be 180 minus 95 minus 60. So if I work that out, angle A is going to be 25 degrees. Okay, so we have 25 degrees for angle A. All right, now I want to find either side A or side B. Maybe we could start out with side A. Now, notice this is not a right triangle. So if it's a non-right triangle, there's two things I cannot use. So this is a non-right triangle. We call that an oblique triangle. So a non-right triangle we call oblique. Well, I cannot use sine A equals opposite over hypotenuse. I can also not use a squared plus b squared equals c squared, because these two formulas only apply to right triangles. Remember, in these two formulas, I would have to know what side is the hypotenuse. But there's no right angle, so there's no hypotenuse in this triangle. So I can't use these formulas. But what I can do is use a formula called law of sines. And that's what the section 8.2 is all about, law of sines. So here's what law of sines says. You could take the sine of an angle over its corresponding side A and set it equal to the sine of any other angle divided by its corresponding side. Okay? So usually what you can do here is go to this setup that I just wrote out and circle what you know or what's given in a problem. Well, we know angle A, I'm going to circle it. We know angle B, I'm going to circle it. We know angle C, I'm going to circle it. We also know side C, so I'm going to circle it. And side A is the unknown quantity that we want to figure out to begin with here. What that tells me is I could take this first fraction and set it equal to this third fraction. Because if I do that, I know 3 of the 4 unknown quantities, I'll be able to solve for the 4th quantity. So I'm going to do that over here. I'm going to write sine A over A equals sine C over C. And really with this law of sines, you could set any one of these, any 2 of these fractions equal to one another. All right, let me go plug in. This is going to be sine of 25 degrees over side A, which is unknown. And that's equal to sine C, which is 95 degrees, divided by side C, which is 8. Now, anytime you have one fraction equal to another, we can cross multiply. So this is going to be A times sine 95 degrees is equal to 8 times sine 25 degrees. I want to get A by itself, so I'm going to divide both sides here by sine 95 degrees. Okay, that's going to let me calculate side A. I'm just going to type this into my calculator all at one time. So I'm not going to do this one step at a time where, I'll find sine 25 degrees first and write that down, and then find sine 95. That's too much effort. It's much easier for me to just enter this all at one time in my calculator. And when I do that, I'm ending up with side A equal to 3.393, and they're asking us to round to 2 decimal places. So it looks like my answer here is just going to be A equals 3.39. All right, so we know side A is 3.39. But they also want us to figure out side B. Now, again, I can't use Pythagorean theorem to figure out side B because this is not a right triangle. But I can use law of sines. Because now, how about if I go ahead and set these 2 fractions equal to each other? Okay, so let me do that. I'm going to write it as sine B over B equals sine C over C. In our example, that's going to be sine of 60 over side B, which is unknown, and that's going to be over equal to sine of C, which is 95 degrees. Side C is 8. Again, I'm going to cross multiply, so it looks like B times sine of 95 degrees is equal to 8 times sine of 60 degrees. I want to get B by itself, so I'm going to divide both sides by sine 95 degrees. So that's going to leave me just B on the left side, and I'm going to work out on my calculator 8 sine 60 divided by sine 95 Again, double check that your calculator is in degree mode when you do this. And it looks like I'm ending up with B equal to 6.954. They want me to round to 2 decimal places, so it looks like my answer here is going to be B equals 6.95. Okay, so I think we have everything we need to plug in. We found that angle A was 25 degrees. We found that side A was 3.39 and side B was 6.95. Being careful to round according to the MyMathLab instructions. All right, well, let's do maybe one more example where we look at a kind of a real-world application using law of sines. All right, so here's what they're giving us. They're telling us an awning covers a sliding glass door that's 88 inches tall, and it forms an angle of 50 degrees with the wall. The purpose of the awning is to prevent sunlight from entering the house when the angle of elevation of the sun is more than 55 degrees. That's angle X in this diagram. Question is, find the length L of this awning. All right, well, let's see here. They're giving us that angle X is 55 degrees. Okay, well, can I figure out this angle right here? I'm going to call this angle B. I can figure out angle B because you might notice angle X plus angle B is forming a right angle, 90 degrees. I know that because this side of the door is labeled as a right angle, so that must mean this side here I could also represent as a right angle. Well, that must mean that angle B is 90 minus angle X, but they told us angle X is 55 degrees, so that tells me that angle B is 35 degrees. Okay, so let me draw a diagram to clarify our triangle here. So I'm going to draw a triangle like this. We know this is angle A, 50 degrees. We know this is angle B, 35 degrees. Well, of course, that means I can figure out angle C using the fact that all three angles have to add up to a right triangle. So it looks like angle C must equal 95 degrees. Okay, and they gave us that the length of this side was 88. We're going to call that side C. And really the question here is find side B. All right, notice this is not a right triangle, so I can't use, you know, the sine of an angle is opposite over hypotenuse. I can't use Pythagorean theorem, but I can consider law of sines. Let me write out law of sines. It's sine A over side A is sine B over side B is sine C over side C. And here's what I'm going to do. I'm going to circle what I know and then see if I can write an equation to solve for the unknown quantity. Well, I know angles A, B, and C, so I'm going to circle those. And I know side C, and the unknown quantity is side B here. Well, that means I'm going to set up these two fractions equal to each other. Okay, let me do it. It's going to be sine of angle B, which was 35 degrees, over side B, which is unknown. That's going to be sine of angle C, which in our diagram is labeled as 95 degrees, over side C, which was given as the height of the door, which is 88. All right, well, one fraction is equal to another. That allows me to cross multiply. So B times sine of 95 degrees is equal to 88 times sine 35 degrees. I want to get B by itself, so I'm going to divide both sides by sine 95 degrees. That cancels out on the left side, and now I'm going to go to my calculator. Again, I'm going to type this all in at once on my calculator. I'm me show you what I'm typing in on my calculator. So on my calculator, I'm just typing in 88 times sine 35 divided by sine 95. So again, I'm letting my calculator do the work for me, and I'm not trying to write down any intermediate results because that usually introduces rounding mistakes if I do it. So it's much better to let my calculator do this calculation all at one time. If I do that, I'm getting the answer 50.667, but it looks like they want me to round to 1 decimal place. So it looks like B is 50.7. So the length of this awning should be 50.7. So let me type that in. And notice here, drawing a diagram is very important. Figuring out the unknown information is very important. And also writing out law of signs in this way, I think is a good idea. Circle the information that you're given, and then that will allow you to set up one fraction equal to another where you need to know 3 of the 4 unknown quantities. All right, hope this is helpful as you're working in the Section 8.2 homework.